Hey class, it's Mr. H here. Going to try some 6.4, more on the graphs of sine and cosine, some different translations. We'll focus on horizontal and vertical translations. To start that, let's do some experimenting. So there is the graph of sine x. Good to pretty much just know what that looks like, right? At least one cycle, right? This little pattern, okay? And then we're going to compare that to the graph of sine of x minus pi over 4. So that pi over 4 in parentheses with that x. What happens if we have that in there? And you can always get a graph by plotting points. So let's plot some points here and see what we come up with. If I plug in pi over 4, maybe I can work it out over here. I'm just going to have sine of pi over 4 minus pi over 4, which is equal to the sine of 0. And when you're trying to calculate the sine of 0, refer to your unit circle. That's the angle 0 radians. Look at the y coordinate at that angle and you'll see that it's 0. So that would be that value there, okay? For 3 pi over 4, I'm going to do 3 pi over 4 minus pi over 4. And 3 minus 1 is 2, so that's 2 pi over 4, which is sine of reducing pi over 2. Pi over 2 is 90 degrees. We're at the top of the unit circle. So at that 90-degree mark, the y coordinate, if you look at it, you'll see that it's equal to 1. Okay. And then I'll go through the rest and just talk through them. If I plug in 5 pi over 4, subtract pi over 4, that's 4 pi over 4, which reduces to pi. Looking at pi, or 180 degrees on the unit circle, I see the y coordinate is 0. 7 pi over 4 minus pi over 4 is 6 pi over 4, 3 pi over 2. Bottom of the unit circle, the y coordinate is -1 there. Finally, 9 pi over 4 minus pi over 4, 8 pi over 4, which reduces to 2 pi, sine of 2 pi, back to 0. Okay, so those are the 5 points that I would like to graph. Now on this next set of axes, I'm going to graph the points I just found and then compare it to the original graph of sine x. So I've already pre-labeled the x-axis just in intervals of pi over 4, right? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and then reducing as I go. Okay, and then the x and y as just 1 and -1. No fancy amplitudes on this one. Okay, so for the sine of x minus pi over 4, let's do it in red. I'm just plotting those points that we just found. So at pi over 4, it was 0. At 3 pi over 4, 1. 5 pi over 4, back to 0. 7 pi over 4, -1. And then 9 pi over 4, back to 0. So I had to kind of get that extra point here. And then there you go. Okay, so there's the graph of the new one, sine x minus pi over 4. How about just sine x? So I'm just going to use that guy. Right. Let's do that one in blue. And so that one was at 0, it's 0. At pi over 2 is 1. Pi, here's 0. 3 pi over 2, -1, and then 2 pi, 0. That's the standard sine wave. Okay, and there's the comparison. As we can see, what happens when we put that little minus pi over 4 in there, it shifts the graph horizontally to the right. Right, so make note of that because it was a minus, but it shifted to the right. So if you have a minus in the parentheses, it's going to be a right shift. Okay, so in words, the graph of sine of x minus pi over 4 can be obtained or is obtained by shifting the graph of f of x equals sine x pi over 4 units to the right. That's my wife's phone going off. That's okay. All right. Vertical translations. Let's do a new graph. 2 plus sine x. Let's go back to black there. I'm going to plug in those key points and then calculate sine x plus 2. Okay, so what if I plug in 0? The sine of 0 we know from unit circle is 0. 2 plus 0 is 2. If I plug in pi over 2, the sine of pi over 2 is 1, right? So maybe I'll do this one, like, I'll work it out so you can see one worked out. 2 plus sine of pi over 2. If there's sine of pi over 2, go back to unit circle. That's equal to 1. So this is 2 plus 1, which is 3. 3. Pi, sine of pi is 0. 2 plus 0 is 2. 3 pi over 2. The sine of 3 pi over 2 is negative 1. 2 plus negative 1 is positive 1. And then 2 pi is 0. Sine of 2 pi is 0. 2 plus 0 is 2. Okay. Let's plot those. And we're doing that one in red because it's red right there. Okay. So let's label the axes. I didn't label these yet. So this one's just our standard pi over 2, pi, 3 pi over 2, 2 pi. Okay. And then let's just do, 1, 2, 3. All right. Negative 1, negative 2, negative 3. Okay. Back to red, graph it, plot those points. So we've got 0, 2, pi over 2, 3, pi, 2, 3 pi over 2, 1, 2 pi. All right. So it looks a little flatter. That's just the way I labeled the axes. Right? That's my scaling. And then let's get the regular sine wave, which is 0 up to 1, back to 0, down to negative 1, back to 0, right? Your standard pattern. And what I see here is that the 2 out front causes the graph to shift vertically up 2 units, right? Every point just shifted up, right? All those points shifted up 2 units. Otherwise, the pattern is the same. All right. So the graph of 2 plus sine x is obtained by shifting the graph of f of x equals sine x 2 units up. Right. So let's summarize here a generalization of all of this stuff that we've seen. We've got 4 things going on basically. So now I'm looking at just generally speaking here of sine and cosine. Amplitude is the absolute value of A. Cool, got that. Period 2 pi over B, that's from last section. The phase shift is just D, right? Phase shift is another word we're going to use for horizontal shift. It's just the number that's being subtracted inside there, right? Now look at that sign, right? If it's a minus sign, it's to the right. If it's a plus sign, it's to the left. And then the vertical translation is just that number being added on the outside of the function, the C, okay? And then a note, if A is negative, reflect the graph about the x-axis, flip it upside down. Okay, let's try some of these out. So I'm not worried about graphing these right now. I just want to find those 4 key pieces of information. Okay, so for number 1, how about the amplitude? Just look for that number out front, ignore a negative. So the amplitude would be 3. Okay, for the period, look for the coefficient of the x. So in this case, it's 1. So that's going to be 2 pi over 1, right? Using that formula, 2 pi over b, right? Thinking of that 1 right there, which is just 2 pi. The phase shift's on the inside. That's pi over 3. Now there's 2 ways you can do this. You could just say it's pi over 3, or to be specific, pi over 3 units to the right, right? Okay, to shift to the right. And then the vertical translation is 0, or there is no vertical translation because there's no number added on the outside of the function. For number 2, Amplitude is that value right out front of the sine function, 2/3. The period is 2 pi over 4, right, which is reduced to pi over 2. Phase shift, I could say negative pi over 6, right? It's opposite that sign. Or just say pi over 6 units to the left. Right? So those are two ways to say it. Either just say negative pi over 6 or pi over 6 to the left. Okay. So again, there's that opposite sign thing going. It's a plus here, so it's a left shift. Vertical translation, again, there is none. No number added on the outside. Let's continue. How about the next one? Amplitude, I can identify it. It's the 5 right out front of that sign. The period, 2 pi divided by a half. Right? That b is always right in front of the x. Okay. I'll get to why we have brackets and parentheses in a minute, but for right now, just think of right in front of the x. This is going to be 2 pi times 2 over 1. So 4 pi. Phase shift, there it is. Negative pi over 4. Or you could just say pi over 4 to the left. Right? And then vertical translation, now we've got one. It's that number out front there, 4 units up. Right? That one always matches the sign. So if it's positive, it's up. If it's negative, it's down. So 4 up. Next one, amplitude, 4. Don't worry about that negative. That just flips the graph over. Period. Okay, now I've got some issues because I don't have the value factored out. Okay, so I kind of want to make it look like that one. And that's really going to affect the phase shift as well. So if you have one that's not factored out, you're going to do a little algebra and factor that out. Just think of this inside the parentheses. What I want is to take out, like think of that as a 1x, a 1/2 x minus what? If I factor out a half from algebra, what would I put here? So that 1/2 times that is equal to pi over 3. Right? Or you're dividing out the 1/2, right? Just timesing by 2. So that would be a 2 pi over 3. Okay, so notice if you multiplied those two together, the 2's would cancel and you'd be left with pi over 3 again. It's important to do that step because that's going to make your phase shift correct. Okay, so now for the period, I'm going to use that guy. Why did I erase it? I meant to highlight it. We're going to use that guy. So we're going to do 2 pi divided by 1/2, which is exactly what we did in the problem number 3, 4 pi. For the phase shift, there it is now. We've done all this work. We've got the phase shift. It's 2 pi over 3 to the right. Right? Because it's a minus sign, so it's to the right. And then vertical translation, that's that number, -2, or you could just say 2 down. Okay, there we go. All right. So we try another one like that where we have to do that factoring. I might just start with that. Let's just do it down below. So I'm going to take the 2 out, and then I'm going to be left with x plus what? What would go there? So 2 times what would give me pi over 4. Right? And I see that that's going to be pi over 8. Because the 2 and the 8 would cancel, and you'd be left with a 4 in the denominator. All right. Now let's knock out these features. Amplitude, 1. It's the number out in front of the sign. All right. Just think of there's a 1 there. Period, I've got to do 2 pi divided by 2, which reduces to pi. Phase shift, I've got it now. It's pi over 8 to the left. Or you could just say negative pi over 8. Again, there's 2 ways to say it. Pi over 8 to the left or negative pi over 8. I think in the homework, a lot of times they'll use the left-right thing, so they'll have pi over 8 to the left. And then the vertical translation, 6. 6 up, positive 6. All right, one more. Let's factor out that 1/4. If I take a 1/4 out, what do I multiply by 1/4 to get pi over 16? Or just take pi over 16 times 4. It should be pi over 4. Right? And 4 times 4 would give you that 16 if I redistributed that value. Okay. Okay, amplitude 3/4. Period 2 pi divided by 1/4, which is 2 pi times 4, 8 pi. Phase shift, I've got it now. Pi over 4 to the right. And then vertical translation, 4 down, or -4 if you prefer. Okay, and there we have it. All right, that's it for now. In the next video, we'll do an application, and then we'll do some graphing using the graphing tool that you find in MyLab. Okay, hope all is well. Send questions my way if you have any. Talk to you later.